All right, let's do this. So we're going to start with some coding example. We're going to hang out in VS Code for a second here before we head over to the slides. And today is one of the... where were we? Today is one of the non-Python examples, so I'm going to show just a little bit of Node.js code. For those of you who haven't heard of Node.js before, it's JavaScript, but you can run it outside of the browser. And we can use it to write web servers in this case. So Node.js is JavaScript, but server-side. Or not even necessarily server-side, but just outside of the browser. You don't even have to write web code with this. You could write whatever you want with JavaScript using Node.js. So we're going to import the net library. This is going to be the equivalent of socket server in Python. This is going to give us our TCP socket server. We're going to create our server. At the bottom, we're going to run that server by listening, by listening on localhost port 8000, just like we were in Python, just a little bit different syntax. And this is going to take a socket, and then we're going to use a listener. Whenever we receive data on any socket, we're going to call this function with the data that's received. So a bit of a different setup. In most languages you would use in this course, that you could use in this course, or at least every single one that I've seen, there's one of two different approaches. The Python approach, where you get a method called for every single TCP connection, and this strategy where you get a callback called for every time there's data received. So you either react to data being received or you react to connections being established. So there's a big difference between Python and JavaScript in this case, in this sense. So whenever data is received on any socket, you'll have access to the data. It'll call this callback function. You'll have access to the data and the socket through which that data was received. So you have access to all the information that you need. This data will be in the same as when you call the receive method in Python. It'll be bytes, and then you'll have to treat it as a string if that's what you're doing, or whatever you're going to do with your bytes. You're going to do the same thing that we did in Python. I just want to get the host name and port for the connection, which should be localhost when I'm testing, and then whatever very large 5-digit port number my browser decided to grab. Just printing out that I received some data and print out the length of that data. Convert it to a string and show me what I got. And then I'm going to just respond with hello, but I'm going to respond with hello and some non-ASCII characters just so we can see some non-ASCII in action. I'm doing something a little bit different here. I'm calling a function called buildResponse, and this is the first of many times where I'm going to strongly recommend something, and most of you will ignore me, and that's fine. As long as you don't have issues and come to office hours with it's also fine. You can still come to office hours, but we might make fun of you a little bit. I'm not make fun of you, but make fun of your code, I should say, is to write helper methods. This is something you've been doing since the beginning of 1.15, yet left to their own devices, most students won't do this. And it's a habit you got to get into. Before you get out there in your career and you're writing professional grade code, if you're not even using helper methods, it's like the very first starting point of how you can write good code. And we teach you this from the beginning of 1.15, so please at least do this. I'll have a lot more recommendations of how to organize your code, but at the very least, write yourself some helper methods. It'll save you a lot of time and frustration. So I have a helper method called buildResponse, which is going to take my response code, my content type, and then my content itself, which buffer.from is the same as .encode in Python. This is taking my string and converting it into an array of bytes. So this buildResponse is going to expect any bytes, which might be a string, it might be an image, like in Application Objective 1, it could be an image, it could be a JSON string, which is just a string to the internet, to HTTP. But it could be anything as long as it's bytes. So I'm converting my string into bytes and then sending it to this method. And then in the method is where I handle all my HTTP stuff. This way I only write the HTTP stuff one time, And then I might update this method. When I build out the server, when I have larger servers, I update this method to take any number of headers, usually some key value store of headers, and then it'll iterate over those and build all my headers. So this is a bare bones one that I would first start off with. It's going to splice in the response code where I want. It's going to have my new line characters the way I need it. Content type is whatever I passed. Content length. Remember, I'm calling this method with the string already converted to bytes. So I can just hit this with a dot length. Give me the number of bytes in this byte array and just use that as the content length. I don't have to worry about it being a string because it's already not a string. I can't even make that mistake. If I call this method with a string, I'm going to get an error because it's just not going to, right when I get here, I'm going to get an error because it's not the type that I'm expecting it to be. Or at least I should get an error. I think that would give an error. And then that's going to catch me before I make a bigger mistake, before I spend an hour debugging something that, you used the length of the string instead of the number of bytes. This will, among other things, help me fix that, help me avoid that bug. My blank line character, and then the content of my response. So all of this, I'm building the headers. This is how we're concatenating 2 byte arrays in Node. So response is a string, so buffer.from to convert it into a... Oh, I shouldn't even have this buffer.from right here. Buffer.from to convert it into bytes. And then this buffer.from actually shouldn't be here. I know it works, so I'm going to leave it there. Buffer.from converting a byte array to a byte array apparently just returns it. So it looks like I got away with that one. But that buffer.from shouldn't be there because this is already in bytes. And then return that. And then that return goes right into socket.write, which sends data. This is like send all in Python. Socket.sendAll. So socket.write, send that information back to the client. That's not exactly what we want to talk about today. Today we want to talk about Docker. And here's my Docker file that I have set up, which is going to run that server in a Docker container. This is our brand new content that we want to talk about today. And I want to show you how this works first, how we're going to use it, and then we'll go to the slides and talk about what the hell we just saw. So with this, I want to do Docker build -t, I'll just do test. So Docker build is going to build an image based on this Docker file, and I'm going to name it test. Actually, I think I named it test when I was actually testing this lecture, and then a trailing dot. This won't work. I want to call that out just before I hit this so you know I'm not messing up. This isn't going to work for me. I want to show this because this is the most common mistake I do make when using Docker. Docker is software that has to be installed and running on your machine. I have it installed, but it's not running right now. I always forget this. I got to run Docker. And then once it's running, there's something to listen to that Docker command. Without Docker running, there's nothing to listen into my command. So nothing happens. So let me run that. I can see it starting up. I'm going to try to run it even though it's in startup process still. It looks like it worked. And we get a whole bunch of stuff. This will usually take a long time to run, but I already built this. And Docker's really smart about using pre-built stuff. Even though I'm creating a new image, it'll use all of the stuff that I've already built. Very much like Git with a working tree that it works off of. All it did was re-tag one of those nodes on the working tree and label it with my new image name. It's really smart about that. So that went really fast. It'll usually go really slow the first time you build something. And then I want to do Docker run -p. I'll do 8080:8000. Would I name it lecture? I'm already using port 8080. Just go 8082 to be safe. That's going to run my server. Localhost 8082. I should see all my characters there. Another thing I haven't quite showed yet, I'll show this off a lot in future lectures where I have time to do it. Today we got to get to Docker, but I'll show a little bit. If I go to the Network tab in my Dev Tools, I can see the request that was sent. So I got a request for the root path. It responded, my server responded with a 200 OK. And I can see that my content length was set correctly. The way I got the length of the byte array instead of the length of the string. You notice I have 10 characters here. There's 10 characters total, but 4 of those characters are non-ASCII. So my content length is much more than 10. If I got the length of the string, I'm not getting all of my content displayed on the page. Those characters are 4-byte characters, so we get quite a bit more information, quite a bit more bytes than we would expect if they were all ASCII characters. So make sure you don't use the length of the string. The length of the string does not equal the number of bytes in the body of the response. So any questions before I jump over to slides? Anything you want to see while I'm demoing things? Is this still using seconds? No, this is Node, so it's using something else. Was there a reason he showed us that? Yes, for JavaScript enjoyers. That was exactly the answer. Yeah.
What's that dash T option do for
So I'll explain. I will answer your question. I'll answer it right now. I will also explain it when we get to the slides. But dash T means this is what I want to name the image that I'm creating. So I did dash T lecture. That means name this image lecture. And then when I ran the image, create a container, I had to match that name. So I had to. That's where I paused a second and said, wait, what did I name it? I had to match and say lecture. So whatever you name it doesn't really matter as long as you're matching when you build and when you run. And with that, I should probably give a disclaimer right now. Best time right now is you won't actually have to do what I just demoed. I demoed this to show you how to use Docker. But next lecture, we're going to learn Docker Compose, which is effectively going to automate what we just did. And you will have to set up Docker Compose to do that automation. And I'll make the comparisons. When we set up Docker Compose, I'll show you what it's doing compared to how it's automating what we did today. But things like the dash T, you're not going to have to memorize that. You'll have to memorize some Docker Compose stuff, though. But it's simpler memorization for Docker Compose than for Docker, just raw Docker. So today is just raw Docker. Docker Compose is going to help us create multiple Docker containers simultaneously. So with that, any other questions? What is this dev tool on the browser? It's going to be your best friend this semester. So if you right-click, in most browsers, you right-click and well, you're supposed to see Inspect Element on the bottom. Go to Inspect Element, or you go to Developer and Dev Tools. It's different for every browser, and some OSs are different even with the same browser. But some way to get into your dev tools, it's going to give you this console, which gives you tons and tons of information. One, the source code. The console, whenever you do console.log, this is where your text goes. All of the code associated with the site. And you see all the CSS, the JavaScript. And network, this is where I just was. Usually you have to hit refresh when you go here, but it'll show you all of the GET requests that were needed to generate that page. So at CSE312.com, I remember how I mentioned it's usually a lot of GET requests to load one page. This, my browser sent a GET request for CSE312.com. My server responded with just the HTML, period. That's it, the HTML. This is a common mistake that always happens, and I've seen it in Office already this semester, so it's worth taking some time to talk about it right now. You get a request for the root path. You respond with just your HTML. And this is when you get to learning objective 2. Respond with just your HTML only, period, end of story. You get a request, you check the request line, you see that it's for a GET request for the root path, respond with the HTML, and you're done. You're done with that entire TCP connection. You're just done with it. And then, if everything works well on the browser side, it's going to get that HTML, it's going to parse it, and it's going to say, whoa, I need a lot more stuff here. I need more than just your HTML. And it's going to make a separate HTTP request for each piece of content that it needs. So here, it sent another HTTP request for Bootstrap's CSS, and I responded with Bootstrap CSS. It made a request for UB styling, and I responded with all my style for this page. It made a request for the dark theme and responded with Nicholas's, oh, he's not here today. Oh, man. With Nicholas's dark theme, he contributed the dark theme. If your eyes should thank Nicholas for that. I had light mode all the time. It made another request for my JavaScript, made another request for jQuery, Popper, Bootstrap's JavaScript, in addition to the CS, Socket.io, Font Awesome. I actually don't use Socket.io on this page anymore, but I still have the code there. All the multimedia resources that are needed, and a couple other things. So all those requests were made for a single page load. So on your server, when you're coding your server, when you get a request, you just respond with whatever was requested for. If it's a request for the CSS, respond with the CSS. If it's a request for the JavaScript, respond with the JavaScript. You don't have to code anything that says, there's a user loading the page, they need all this stuff. You just respond with your HTML, and they'll request the rest of the stuff with separate HTTP requests, which will actually be separate TCP connections. You don't even care that it's the same user. You just treat every request in complete isolation. Now, there are ways to preserve the same TCP connection using the keep alive. You'll see those headers around. We're just not going to do that in this class. You can if you want, actually. But it adds complexity that we just don't need to worry about quite yet in 3.12. So when you get a request, you respond with whatever was requested for, and then just let that handle method resolve. Just let it hit the end of the method. When that method ends, the TCP connection is closed. And then the user is going to make another TCP connection to request the next thing. And it's fine. They can do that. We're not too worried about optimizing everything in this class. They'll just have to create a new TCP connection each time. And that's fine. So just respond with what was requested for and close the connection. Okay. All right, any other questions? Or are we on the slides? favicon.ico. That's the icon that'll display in the browser. You'll see in the, not necessarily in the browser, it's this icon right here that shows up in your tab. So you'll see this in your homework too. You'll get requests for that. And I forgot to add it to homework 1. I was gonna, and then I completely forgot to add it to application objective 1. So you don't have to worry about that right now. That'll just fall through to your 404, but the browser will request that. You'll see it in your servers, and it showed up in example code in lecture already on Friday, I think it was, or Monday, I forget when. It showed up, and then I just scrolled past it and tried to ignore it. But you'll see those requests. It's fine. As long as your server doesn't crash when it gets that request, it should just fall through to your 404. That's perfectly fine for our purposes. Let's talk about Docker and what the hell we even just saw. So in short, the demo I just showed, we just ran that Node app without ever calling Node. I just used Docker. I did Docker build, Docker run. I never said Node. I never said npm run. I never said any of that stuff. So let's talk about what happened there. So start with a little vocab. 2 words that you're going to hear all the time, especially if you go into a career in web development. Even if you don't, you'll probably hear these if you're anywhere in software engineering. Prod and dev, or production and development. So your development environment, this is a separate environment than production. Your development environment is your laptop. So wherever you're writing code, your desktop at home, whatever you're writing code on, that's dev. That's the dev environment. It's wherever you're actively developing code, wherever you're writing things. Wherever you're writing code, developing features and stuff. And then prod, your production environment, that's the actual server where the code is going to eventually live. So production is kind of a sacred environment. You don't want to break anything there because end users will see it immediately. Whenever something breaks in Autolab's production environment is the one that affects me the most. I got to go and fix that, and Nicholas has to go and fix it now. But you notice that immediately. We had a day with 8 hours of Autolab downtime last semester, which was awful. It was the worst thing. It probably affected some of you. But errors in production are awful, and we want to avoid them at all costs. It's never a fun time. So our production environment, this is where the end users are actually consuming your product. This is where you actually release your code to users. So 2 different environments, and we have the common issue. It works on my laptop, but I pushed to prod, and it broke, and nothing worked. My new feature didn't work. This happens a lot, hopefully not too much to all of you, but it is fairly common, and it's always stressful. I shouldn't say that in context of the Autolab. We don't do this in Autolab. We have pretty good controls for Autolab. We don't break when we push new features. Thankfully, I should not say that, but because it's going to happen tomorrow. But it works on my laptop. But when I push to prod, everything breaks. There's a lot of different causes of this. I won't read them all, but the ones I came up with here. But lots of different things can happen when you have 2 different environments. I have a Mac that I code on, and then I'm usually deploying to Ubuntu servers. There's a pretty big difference there. It can easily break things. Lots of things can happen to cause this issue. But we have a solution. We've almost solved this these days. There are still bugs that I run into all the time. But we've almost solved this these days. It's way better than it used to be. I'll say that for the very least. We just create virtual machines. So instead of testing my code on my Mac, I'm going to run a virtual machine that's going to emulate the exact environment that I'm going to see in production, test my code there with that exact environment, the exact versions of everything, the exact operating system, everything set up exactly the way that it's going to be in prod. And then in prod, usually we'll just run the same exact VM. We won't even bother trying to emulate exactly the prod environment. We'll just run another VM in prod. That VM should be identical. There are always little differences, little different things that can happen, but the VM should be exactly the same in both environments. You've seen this in 220 at the very least. I believe that's the first time you see this, where you get your own, you get the environment that's identical to the testing environment, and then it gets rid of all those issues of, well, it worked on my laptop, but I submitted it to Autolab, and Autolab didn't like it. I shouldn't say all, but most of those issues are gone. So this is great. And we really like VMs for a lot of reasons, for the consistency reason I just mentioned, but also for security. If you're running someone's code in a VM or an attacker gains access, we're talking in the context of web servers in this class, of course. So an attacker gains access to your server. They write some malicious code. They get in. They have a SQL injection that gets their profile admin access, and they log into your server, and they can just do whatever after that. And they can just destroy things. Well, if your code is running in a VM, this is, of course, still terrible because if they can access sensitive data, they access private information of your users. This is still absolutely awful. Don't get me wrong. But they can't destroy your actual server itself because they just wreck that VM. And if everything's working the way it should be, they can't escape out of that VM. Of course, there are some very sophisticated attacks where you can break out of a VM, potentially. But if they can't break out of that VM, they just destroy that VM, and then you wipe the VM, you update your code, figure out how they got in, you fix your vulnerability, and then you recreate the VM, and your app's up and running again, and you're live to your users again pretty quickly. Hopefully pretty quickly. It depends how long it takes you to code the bug. But you're not reinstalling an operating system. You're not resetting up your entire box. You don't have to start from step 1. You just hit your button, because hopefully you're automating your creation of the VM. You just hit your button, and boom, VM's back up. In a perfect world. Always, I'll try to not keep belaboring this point, but something always goes wrong. It's development. Something always goes wrong. But it simplifies the process. That whatever goes wrong is going to be easier to fix than if you didn't run VMs. So it's going to make your life simpler, not necessarily simple. And there are times where this security feature is absolutely required. So AWS, Heroku, DigitalOcean, anything where you can host your code, they have to run untrusted code. They're not just going to say, yeah, have access to our servers, and then just trust that 0 malicious hackers are going to ever use AWS. Not going to happen. They're going to do things. They're going to try to take their AWS instance and try to break things, try to get out of that. People are going to try that. So that code has to be run in an environment that doesn't have to be trusted, and that's going to be a virtual machine, or as we're going to talk about, containers. The Autolab also. I don't trust all of your code. I know some of you have tried to break Autolab and tried to destroy the server. Maybe not in this room, but students in the past. Usually TAs, or if they're not TAs, I usually hire them as TAs, to be honest. But if you're trying to break things like that, usually you know what's going on. One of the students who tried to break Autolab, who did successfully break Autolab, let's not get it twisted, is an alumni, graduated like 3 or 4 years ago by now. Man, time goes. But and he's still working on the Autolab team. I hired him as a TA, then brought him into the Autolab team, and he's still working on it on a volunteer basis. So if you're trying to break Autolab, let's talk, let's chat. Tell me what you did. Tell me how you broke it if you're successful. I'll have opportunities for you. But I don't trust everybody's code. Autolab has to be set up to run untrusted code, and it does that with containers, which we'll introduce in a second, where even if you do, in your submission, you say run a, I was blanking on the word, run a syscall of rm-rf/. If you run that, you absolutely wreck that container. It'll be completely destroyed. But what Autolab does is once your code runs and we get your feedback, which in that case we wouldn't get any feedback, we destroy that container. And then when another submission comes in, we create another container. Run the code in there, destroy that container. It's just one use only. There's nothing you can actually break aside from trying to actually escape the container itself. Would be the only possible thing, and we have all kinds of checks to make sure you're not doing that. So you can break that instance, that environment where your submission is being graded, and that environment only exists to grade your one submission, and that's it. And if you ever wondered why Autolab takes at least 10 to 15 seconds of overhead, even to grade Hello World, even the simplest assignments, that's why, because it's got to spin up a whole container, build that whole instance of Ubuntu, and then destroy it afterwards. So it takes a little bit. There's overhead. It's one of the downsides, but it's a lot better than just saying, hey, don't hack me, please. Don't break Autolab. Not going to happen. So it's really nice for when we have to run untrusted code, especially. But we're not going to talk about VMs at all. We're going to talk about containers, which I only have a one-line explanation of what containers are. Basically, lightweight VMs. With VMs, if you ever dual-booted your machine, or not dual-booted, but used virtualization, VMware, and ran 2 operating systems on your machine, it takes a lot of resources just to run 2. If you're trying to run more than that, it's difficult. Containers are much more lightweight. You can have lots. I'll leave it vague, but lots of containers running on your machine. If you want to run a handful of containers on your laptop, it should do that without too much trouble. It does still take a lot of RAM. It is still doing a lot of work. But you can run multiple containers or a single container without barely noticing too much, aside from Docker itself's overhead. Docker running without any containers running still takes a lot of resources, but so does Chrome these days, so you can't really blame Docker for that too much. But these are the new thing, but not so new anymore. They've been around for a while. But when containers came out, we liked our virtual machines and our virtualization. When containers came out, it just swept the industry very quickly. It was one of them things where I started hearing containers existed, and it seemed like the next day, everybody was using containers. It took over so fast. It was industry was very quick to adopt this technology, and it's just everywhere. You're going to run into containers in your career, almost certainly, especially if you're getting into web dev. You'll be using containers. And we're going to use Docker to build those containers. There are a few alternatives, but Docker has been the winner. This is the one that is most popular out there. Docker is software that's going to create our containers for us. So Docker is software. It has to be downloaded, installed onto your machine. Install Docker. If you have a Windows machine, I feel a little bit bad for you, but not too bad. That it is a bit of a pain. You have to download the Windows subsystem for Linux. I always get these in the wrong order. WSL. You have to install that, and to be able to get your hypervisor, I forgot the details. Something about a hypervisor. Docker needs a hypervisor to run, and Windows doesn't play nice like that. So you have to get WSL to get the hypervisor. That is all stuff you have to do if you're a Windows user. For Mac and Linux, any Unix-based system, You already have the hypervisor. It's all set up and ready for Docker. You just install Docker, and you're good to go. But it does need to be installed and ran. If it's not running, you'll get the error I showed off at the beginning of lecture. Docker's not running. It has to be installed and running on your machine. I see that error a lot because I always shut down Docker. I said it takes a lot of resources. It really likes to hog up RAM. So I'll shut it down whenever I'm not actively using Docker, and then I always forget to spin it back up when I want to use it. And then install it on your machine in dev. You install Docker on prod, and then you create containers that are identical in both environments. And then you have very few, it works on my laptop, issues. Still some. There's always user error. I've used Docker incorrectly before and had those errors. It worked on my laptop. But they're limited. Docker starts with a Docker file. So let's take a look at that. It's similar to a makefile in the sense that it's a script that's going to run and build stuff for you. Other than that, it's not too similar to a makefile, but just the fact that it's a file that's going to control the building of stuff. I'll say it's similar to a makefile. And in name, they're pretty similar. So let's take a look at this Docker file, much more complex than the one I briefly showed in VS Code, and more complex than what you'll need. But I want to use this more complex one, so I can talk about a whole bunch of Docker stuff. So this is going to set up and run a node application that's stored in app-www.js, which I'm not going to show the code for. Well, let's just go through this line by line. Let's break this down. So the very first line of your Docker file is going to be the base image that you're going to start with. So there are tons of Docker images that are going to that are freely available to you. If you're interested in them, you can go to Docker Hub, similar to, of course, in namesake especially, similar to GitHub, where people share their Docker images with each other. And any public image is just freely available out there for you. One of those public images is Ubuntu itself. You can, I guess these kind of dating the slides a bit here, that I made these when 1804, Ubuntu 1804 was the cool new thing. But I'm starting with a fresh instance of Ubuntu 1804, and this is going to be downloaded onto my machine. I'm going to get that as a base image, and then that's my starting point. I get a fresh install of 1804, and then I'm going to build off of that to build the rest of my image. So I want an image that's going to have my stuff in it, not just vanilla, plain old, out-of-the-box Ubuntu 1804. But since we're starting with Ubuntu, we can run Ubuntu commands, any Linux commands that we know. So if you're wondering what to put in your Docker file, you can Google Ubuntu, how do I do XYZ? And most of it's going to be the same, except some notable differences we'll see. But we're going to use the run keyword to run any Linux commands. So in the command line, if you're going to set all this up to be able to run node, one of the first things you'll do is update apt-get, your repository for all of your programs to install. We're going to update that. Same thing with the Docker file. We're going to do run, and then whatever Linux command we want to run. Effectively in an Ubuntu command line. It's going to run in that environment, in a similar environment to that. Next, and this is optional, but I always like to do it, I'm going to set and I want to show it off because there's a few commands here. I'm going to set my root, my home directory to /root. So in Docker, you're going to be running these commands as the root user, so I don't need any sudos on any of this stuff. We're running as the root user, and I'm going to set my home directory to /root. I think I found this in documentation one time, but I really liked it, so I keep doing it. But what this is doing is setting my home environment variable. So env to set an environment variable. I'm going to set the home variable to /root. So this sets my home directory to /root. And then I'm going to change my working directory to /root. So work dir is the same as saying cd. We're cding into this directory effectively, but work dir in your Docker file. So what I've done is moved into the /root directory, not the root directory, the directory /root, and I set that directory as my home directory. And now I know when I work in this container, I know that that directory is going to exist and it's going to have my stuff in it. That's where I'm going to be working, is this root directory. Bless you. So I don't know, I think this might even be the default when you create a container, I forget. But I don't know what the default is if you don't change your working directory, like what your directory is going to be in Docker, or what your home directory is going to be. I actually forgot what they are, because I'm going to do this in every single Docker container I have. I might change root to something else if I have some other meaningful directory name that I want to use. But this is going to be make me 100% certain that I'm working in the directory /root. So I don't have to have any questions of where my stuff is. Am I working in a directory over here and my stuff's over here? No, I'm in this home directory and I'm working in this directory. I know 100%. /root is where all the things are happening. And then I'm going to install Node. So vanilla Ubuntu isn't going to have Node and npm installed, so I have to install them. So whatever language you want to use, you would install that, go through whatever procedure you have for installing your language in Ubuntu. Do we need WSL for Docker Compose too? Yes. So Docker Compose just runs Docker. If you don't have, you can't use Docker Compose without Docker already running. And I think I read that Docker, if I'm remembering right, Docker Compose doesn't quite exist as its own thing anymore. You used to have to install Docker and install Docker Compose, but now Docker Compose is just part of Docker. It's just a separate command, Docker space compose instead of Docker -compose for what it's worth. But Docker Compose, we'll be talking about that Friday. So install whatever you need to install. If you need more than just that, you have to install more than that. The Docker files for the autograder containers, there's tons, we install all kinds of languages in there. We got dozens of lines just installing all kinds of stuff for every language. Then, very importantly, copy your files into the container. So you're building this container, or building this image with the goal of running your web app. So your code, your files, got to get in there somehow, and that's how we're doing it. Copy, it takes 2 directories as arguments. Here I'm just doing dot and dot. Dot means the current directory. So I'm saying copy everything from the current directory, which in my case is going to be whatever directory the Docker file lives in. So with this setup, my Docker file would be in the root directory of my project. And I'm going to do dot, which means take everything in this directory, everything in my project directory, and move it into the current directory inside the container, which I know is /root. So copy everything in this directory into the home directory and the working directory, which are the same in this case, but the working directory of the image. This gets all of your code inside the image. Install any dependencies if you need to. Don't forget this one. A lot of you will, because it won't come up until later on in the course. You have to update your Docker file, and things will break, and I'll say you didn't install your dependencies. What are you doing? Don't forget to install your dependencies. Right now in Homework 1, you won't have any. But when you get to, I said later in the course, but I mean like next week. When you get to application objectives 4 and 5, when you start working with your database, you have to install a dependency of the client for your database. Once you have that, you have to make sure it's installed in your Docker image, or else you'll get errors when you try to access Mongo or MySQL. You'll get errors when you try to connect to them. Make sure you install your dependencies when you have them. For learning objectives 1 and 2, and for application objective 1, that won't come up. But once you hit application objective 2 and you start talking to your database, it'll come up. And if you say, well, I'm just going to skip 2 and 3, I'm going to skip those objectives, it'll come up in homework 2, like right away, right in the learning objectives. And then we're going to expose a port. This app's running on port 8000. So I'm going to expose port 8000 to make sure that it's accessible from outside of the container. By default, all ports are closed. You can't access a container from the outside world, or from my laptop. I can't access that container with TCP. So we have to make sure we explicitly allow certain ports. This is technically optional. The way we use these, Docker Compose is going to open up those ports. But just to be extra safe, I always leave it in here anyway. If nothing else, it serves as documentation to say, hey, this container, this eventual container, is going to be accessed through port 8000, and I'm okay with that. Then finally, use command cmd to run your app. Importantly, don't use run to run your app. Yeah, I know that's confusing, but use command. So run, any commands executed with run are going to run when the image is being built, and command is going to execute when the container is ran. So when we run the container, everything else has already run at that point, and then we're just going to run whatever the command is. And there can only be one command. That's your entry point into the container. When you run a container, that's what's going to run. But command to start your app, run to do any setup for the image before your app runs. And we can simplify a lot of that. So that's in general, that's a general use case. You start with an Ubuntu image or whatever image you want to start with and then build up to whatever you want. But there are a lot of easier images to work with. Just find an image for your language of choice with everything already installed in it. This image, Node 13, which I should probably update, we're beyond Node 13 now, is going to install Node 13, it's an Ubuntu image with Node already installed. So I can skip some steps where I was installing NPM and Node and doing the fix missing. I can skip those steps and just say, okay, Node's already installed. Let me just do my stuff. I'm still going to set my root directory because I like to do it. Still going to copy in my files. I'm still going to install my dependencies, and I forgot to mention explicitly, but make sure you copy in your files before installing your dependencies. If you do this before, there's no package.json to find your dependencies. In Python, there's no requirements.txt in there because you didn't copy in your files. You got to copy in your files before you have any dependencies to install. So make sure you copy in your files first. Install your dependencies, expose your port, and then run your app. So we can skip the installation of Node by just grabbing an image out there that somebody made available for free. Just grab that image that already has your language installed. And most of you are going to use Python, just from Python. Again, I could update that. If you're using newer language features that weren't in 3.8, you can update that. 3.8 is still going to work for you, though. From Python, and then make sure you copy in your files first, and then install your dependencies. And I think this is the most common thing that I see. They'll take my Docker file. Like some of you might be typing it up right now. You'll be like, oh, that Docker file, I'm going to use that. But you don't have a file named requirements.txt in your project. Bless you. Please, when you're typing these things, pay attention to what you're typing. If you don't have a requirements.txt in your project, this is going to break on this line because you don't have that file. Why would you type that and be, okay, install requirements.txt when there is no requirements.txt? So if you're using this just character for character, make sure you have a requirements.txt. If you don't know what a requirements.txt is, look it up, get used to your Python. I assume most of you you've used that before. Maybe you haven't. Maybe I should explain that a little bit. No, you use it in 1.15, don't you? Use it in 1.15. Y'all know what requirements.txt is. But it's a list of all your dependencies. Python keeps this really simple. It's a list of all the external libraries that need to be installed. And will read that file and install all those packages. When you're running Python, this one, you should copy character for character. Unlike what I just said, have this -u in there. It will save your life, I promise. This is the best thing when I found this out. A student pointed this out to me once, that, hey, you can just have a -u there and it's going to save you lots of frustration. And it does. So when you run Python inside a Docker container, it will buffer your output. So when you print things to the screen, most of the time you never get to see what you printed to the screen, and you don't get to see all of the feedback that your app is showing you. Like the requests coming in, the responses going out. Sometimes you can print those and get an idea of where your bugs are and help your debug cycle. Those are all buffered, and you won't see them until there's a lot of output. And then the buffer will fill, and then it'll dump the buffer to the screen. -u says, unbuffer that. Don't use a buffer. Just give me the stuff that I print to the screen. It makes life a lot better. So just don't forget that -u. Have that -u, get unbuffered output. So whenever you print something to screen, you see it right away. Okay, and now we're ready to actually build a container. Everything we just talked about was about images, and we don't really care about images that much. I mean, we do, but images are just a stepping stone to get to containers. Containers are what we care about. Containers are what's going to run our app. So the parallel here is images to containers. It's like classes to objects. Our image is going to be used to create as many containers as we want. In our case, one. We just want one container of our app. But the image is going to create as many containers as we want based on that image. And then when we run the image, or when we run the container, that's actually going to run our code. We can't run an image. It's just used to create containers. So to build the container, the very first thing we did, docker build -t, whatever you want to name your image, and then dot. So in your command line, docker build -t means I'm going to give this image a name. If you don't have -t in a name, it'll give you a random name, I believe. I don't know. I always name my images. This will define what image you want, the image name you want. And then this trailing dot, it's not a typo. It is there for a reason. The last argument here is the directory containing your Docker file. And if you run this command in the directory where your Docker file lives, dot, just the current directory, that's where you look for the Docker file. If you don't have this dot, it won't work. It won't find your Docker file, and you just don't build your image. It doesn't work. So you run this, and then you wait for a fairly long amount of time. The very first thing you'll see is a lot of downloading happening. That's downloading your base image from Docker Hub, and then it'll run all of your commands one at a time. You can see progress bars for each one and all the output for each one. That gives us an image, and then when we want to create a container from that image, we do docker run. So we're going to run the image, which is going to create a container, and then run that container. So docker run -p and all this stuff, let's talk about it. So -p, local port to 8,000. So the 8,000 is actually not always 8,000. It's whatever you want it to be, whatever you want to use. My app is running on 8,000. I exposed 8,000, so this has to be 8,000 for this example. It's whatever port your app is running on inside your code. And you might notice I'm always using 8,000, but if you looked at the homework, I require 8080. And you might want to call me out on being inconsistent, and you should, until I explain this part. So this -p local port to 8,000, this is going to map a port on your machine to a port inside your container. And this local port is how you're actually going to access your app. And for your homework, the local port should be 8080. And when I did the example, I did 8080 as my local port, and then I already have something running on it. I got port already in use, so I had to change it to 8082. But the local port should be 8080. What's running inside your container, when we're grading, we're never going to care, we're never going to know, as long as you're consistent in your Docker file, in your code, and when you're running, or eventually in your Docker Compose file, as long as you're consistent across those places, I don't care what that port is, as long as your local port that you expose is 8080 for your homework.